Hello my friends and welcome back to the You Can Do TV channel. The natural round log house construction industry in Germany has experienced steady growth, particularly among eco-conscious homeowners and niche tourism operators. These homes are typically manufactured from high-quality northern pine or spruce, harvested from sustainably managed Russian forests. Russia, especially regions like Arkhangelsk and Karelia, supplies over 85% of the round log materials used in German log homes. Logs are generally between 200 to 320 millimeters in diameter and air-dried for 6 to 12 months to a moisture content of about 18 to 20%. Production takes place in specialized Russian facilities, equipped with CNC lathe systems that mill each log to precision, ensuring uniformity and tight joinery. Grooves, notches, and corner joints are cut to exact specifications before the entire log house is pre-assembled in the factory to ensure fit. Once disassembled, the logs are marked and shipped to Germany. Assembly in Germany typically takes 2 to 4 weeks, depending on the structure's complexity. The foundation, usually a concrete slab or pile foundation, is prepared in advance. The pre-cut and numbered logs are then reassembled manually on site, using cranes for larger sections. Each log is placed with insulation material, like flax or jute, between joints. Once erected, the structure is sealed, roofed, and finished internally, using eco-friendly materials. The construction of the double-layered timber plate shell begins with the generation of a 3D geometry based on a free-form surface using a custom-developed CAD plugin. Next, the plate geometry is prepared for fabrication within the same digital environment. G-code is then generated and simulated for a 5-axis CNC machine, enabling precise cutting of 15 mm thick timber plates. An assembly sequence simulation follows, dividing the structure into 6 prefabricated segments. Each segment is individually assembled before being brought on site. The final shell assembly is executed by connecting the segments, maintaining a 150 mm spacing between layers. The total structure weighs 360 kilograms and exemplifies a rapid, automated system for constructing complex timber plate geometries. This section shows the construction of the curved, folded wood pavilion. It began with parametric design and structural analysis, followed by the creation of a 1-to-5 prototype. A full-scale prototype was then developed using curved panels of 77 mm thick, CrossLaminated Timber. Robotic prefabrication enabled precise fabrication of joints, ensuring structural integrity and visual clarity. The shell's folded geometry allowed it to span 13.5 meters efficiently. This thin shell structure, developed by EBA under Professor Yves Wynand, was exhibited at the Academy of Architecture in Mendrisio, demonstrating advanced timber construction techniques. This video showcases 2 custom computational tools used to create a timber folded plate structure with form-fitting integral joints, fabricated using widely available 5-axis CNC technology in timber construction. This video shows the design, production, and construction of the Vidi Theater. It is the first double-layered, timber folded plate structure. These panels, only 45 millimeters thick, span up to 20 meters without columns. Precision milled elements were connected using innovative double-through tenon joints, inspired by traditional dovetail woodworking techniques. The structure required minimal use of metal connectors or adhesives. Each uniquely shaped component contributed to a geometrically complex yet efficient, load-bearing system. The prefabricated elements allowed for fast on-site assembly, resulting in a sustainable, acoustically optimized, and demountable theater space. Deep in the forest or right in your backyard, the Big Mill Basic portable sawmill turns raw logs into usable lumber with surprising efficiency. This compact system, by Logasol, allows users to saw logs on site, reducing the need for heavy transport. The process starts by securing the log with 2 steel brackets and aligning a 2.75-meter guide rail. The brackets are adjustable in 4 fixed 90-degree positions, allowing users to define accurate squared cuts. Once mounted, the chainsaw slides along the rail for the first cut, creating a flat surface. With the first face prepared, the rail is lowered for subsequent cuts. Users can rotate the log and repeat the process to produce beams or rough planks, ideal for carpentry and timber construction. For finer cuts, the timber jig guided by the previously sawn surface is used to slice the core of the log precisely. The height can be quickly adjusted using fixed level scales, ensuring consistent board thickness. A single setup can handle logs up to 80 centimeters in diameter and support guide bar lengths up to 90 centimeters. This makes it suitable for both standard and oversized logs. The system works with chainsaws of at least 3 horsepower and 50 cc for optimal results. Whether shaping frames, benches, or full timber walls, this tool offers flexibility without compromising accuracy. The Big Mill Basic is more than an entry-level sawmill. It's a versatile solution for anyone looking to turn trees into projects. It all begins with a flat surface and a vision, a 6-person cube sauna by Redwood Outdoors, designed not just for comfort but also for hands-on assembly. In this video, you'll see each step laid out clearly, transforming raw wooden components into a finished, functional sauna. The process starts by arranging the sleepers, which serve as the sauna's foundation. Builders align them with pre-drilled staves and use a spirit level to ensure the setup is flat and even. Measurements are taken corner to corner to guarantee square placement. Next, the unique base stave, with 2 convex beaded ends, is positioned at the center. It's secured using the included screws, laying the groundwork for the sauna's base layer. Only staves with pre-drilled holes are used at this stage, and their dado cuts must align precisely, as these grooves support the walls later on. With the foundation secured, builders assemble the back and front walls separately on a flat surface. Rubber mallets help snug each section together. Support strips are then fastened across the top and bottom to stabilize the structure. These walls are placed upright and held temporarily with staves, while final measurements confirm alignment and symmetry. From there, the sauna begins to take shape as rows of staves are tapped into place across the walls, each one checked for tightness and fit. Unlike barrel saunas, every stave in this cube model must be fastened with screws for added stability. As the top nears completion, builders mix full, half, and double flat staves to close any remaining gaps, adjusting with mallets as needed. Metal bands are wrapped around the sauna's ends, not for structural support, but to conceal screw holes and add a clean finish. Once secured and tightened, these bands lock into place. Inside, the assembly shifts to function. Bench supports divide the interior into thirds, with level checks ensuring consistent height. Bench frames are then installed and screwed to supports and walls, followed by seat guards and bench tops. The backrest is added at a height suited to user preference, with flexibility to adjust later. The jump seat is placed last among the furniture features, offering optional seating that folds away when not in use. After checking for level positioning, it's secured to the sauna wall. Then comes the heart of the sauna, the heater. Installed with a 42-inch clearance from the roof for safety, it's encased by a 3-sided fence. A thermometer and heater manual provide exact placement recommendations. Finally, gable boards are mounted to each end of the sauna roof. While not mandatory unless shingles are installed, they provide a finished look and added protection against the elements. Once the sauna is fully assembled, a final inspection ensures everything is securely fastened and aligned properly. Builders then complete any necessary adjustments before the sauna is ready for use. With the structure fully intact, the last step is to add a protective finish to the wood, enhancing durability and aesthetics. This step adds a smooth, polished look to the sauna, ensuring it withstands the test of time. After finishing the protective coating, the sauna is left to cure for 24 hours to ensure all finishes are properly set. With that final touch, the sauna is ready to offer a relaxing retreat, ready for immediate use and enjoyment. Nestled in the forests of Montana, the wood processing facilities of Columbia Falls MDF represent a full-circle approach to modern lumber manufacturing, combining efficiency, environmental responsibility, and advanced engineering. The journey begins at the plant, where wood waste from regional sawmills, including sawdust, chips, and planer shavings, is repurposed into medium-density fiberboard, MDF. This raw material is ground into uniform fibers, then blended with synthetic resin to bind the particles. The mixture passes through a drying system, heated by steam, before being pressed into boards under controlled heat and pressure. This results in smooth, dimensionally stable MDF panels ideal for cabinetry, speaker enclosures, interior doors, and more. The finished boards are trimmed to exact dimensions and sanded for a consistent surface texture. Depending on the customer's requirements, certain batches may also receive melamine coatings or veneer overlays for decorative applications. A key component of this facility is its air purification system. Biofilters filled with organic media, such as compost or bark, are home to bacteria that metabolize airborne pollutants. This method of odor and VOC control is both effective and sustainable, contributing to cleaner air in the surrounding community and reflecting the company's eco-conscious mission. To further improve energy usage, The plant also employs heat recovery systems that capture and reuse thermal energy from the production line. This approach not only lowers operating costs, but also supports the broader goal of minimizing environmental impact. Next, we visit nearby sawmills, where raw logs are transformed into lumber. Each log is debarked and trimmed, then scanned by a laser-guided optimizer to calculate the most efficient way to cut each piece. These scanners assess diameter, curvature, and internal defects, allowing the saws to create maximum usable lumber while minimizing waste. Any byproduct, such as bark or undersized offcuts, is rerouted to the MDF plant for reuse, closing the production loop. In addition to lumber, wood chips that don't meet structural standards are processed into biofuel, supplying energy back to the facility itself. This internal fuel cycle reduces dependence on fossil fuels while making use of otherwise discarded material. Cut lumber proceeds to kiln drying, a process that can take up to 3 days at approximately 140 degrees Fahrenheit, 60 degrees Celsius. This step is essential to remove internal moisture, preventing warping or cracking during future use. Once dried, the boards are run through a planer to achieve a smooth finish, then inspected and sorted into grades before packaging. At the plywood plant, the focus shifts to structural panels. Logs are first steamed to soften the fibers, then peeled into long, thin veneer sheets using a high-speed rotary lathe. These sheets are dried, scanned for voids or knots, patched when needed, then stacked in alternating grain directions for strength. After glue is applied, the veneers are pressed at 255 degrees Fahrenheit, 124 degrees Celsius, to form rigid, multi-ply panels that resist bending and splitting, ideal for construction and industrial use. As demand for engineered wood grows, the plant continues to explore automation technologies to increase throughput while maintaining quality. Robotics now assist in veneer stacking and glue application, boosting both efficiency and worker safety. Finished panels undergo quality testing, including moisture content analysis and shear strength checks, ensuring they meet national standards. Some batches are also subjected to fire resistance and formaldehyde emission tests, depending on their intended applications. By utilizing waste from its own sawmills and nearby operations, it reduces raw material costs and landfill contributions simultaneously. Its rail-connected shipping yards allow large volumes of wood products to be distributed efficiently across the U.S. while reducing carbon emissions compared to traditional trucking. In every panel, plank, and beam lies a deeper story of sustainable forestry, cutting-edge machinery, and a commitment to long-term resource stewardship. Here, nothing is wasted. Everything has a purpose. The Vision R4 by Renggli isn't just a house, it's a revolution in modular construction. This video takes you through the fascinating process of creating the Vision R4, an innovative living space made up of 4 interconnected room modules. Designed to be energy efficient and fully prefabricated, this project reflects the spirit of modern architecture and meets the needs of both today's and tomorrow's homeowners. The journey starts at the production facility, where the 4 modules of the building are manufactured with thorough precision. Here, Advanced techniques are used to ensure high-quality production while keeping costs under control. Each module is crafted with energy-efficient technology built into the structure, minimizing environmental impact without compromising on comfort or design. The modules are carefully assembled in the production plant, using a high degree of prefabrication to streamline the construction process. The focus is on delivering a home that is not only sustainable, but also cost-effective. The assembly process ensures that the house is not just quick to build, but also durable and long-lasting. These steps are carried out with the latest in modern construction equipment and techniques, allowing for both speed and precision. Once the modules are ready, the process shifts to the construction site. Within hours, the 4 modules are transported and placed in their final position, ready to be assembled into a fully functional living space. The rapid pace of the installation is a key feature of the building, demonstrating just how far modular construction has come in terms of speed and efficiency. From the arrival of the modules to the final touches, the entire process takes just 1 day, ensuring that homeowners can enjoy their new home almost immediately. In just a few days, a home is born. Thanks to its intelligent design and sustainable construction, the building provides a perfect balance of modern living and environmental responsibility. The prefabrication process not only ensures a high degree of quality control, but also reduces construction time significantly, offering a solution for those who want both quality and speed. This quick yet high-quality construction process is a hallmark of modern building practices. As the building proves, it's not just about building houses, it's about rethinking how we create spaces for living that are both sustainable and efficient. The integration of cutting-edge technology at each stage ensures that every detail of the building is thoroughly crafted. It's an embodiment of the future of housing, innovative, practical, and environmentally responsible. Furthermore, its flexibility in design allows homeowners to personalize their space while adhering to sustainability goals. The Vision R4 is not just a building, it is a smart solution that adapts to the evolving needs of modern life. With each module's modular approach, the structure sets the stage for future innovations in home construction. The 8FT spindle peeling machine is a key tool in producing high-quality face veneer. This video reveals how the machine efficiently peels wood logs to create smooth, uniform veneer sheets. The process begins with the log being carefully mounted onto the machine, where rotating spindles strip away the outer layers. The precision of the machine ensures a consistent thickness and minimal waste. After peeling, the veneer sheets are inspected and ready for further processing. This system exemplifies modern wood processing technology, delivering high-quality results while maintaining efficiency and precision. Step inside the All-Style Cabinet Doors factory to discover how custom-made solid wood cabinet doors are created. This video guides you through the meticulous process, blending old-world craftsmanship with modern technology. Starting with raw materials, each piece is carefully shaped, cut, and assembled using precision digital technology. This ensures tight joints and exact measurements within millimeters. Skilled artisans hand sand each door, removing imperfections and preparing them for finishing. Whether it's custom closet systems, residential kitchens, or home renovations, attention to detail is key. From design to final touch, the team ensures a quality product delivered with fast lead times. This factory tour shows how expertise, technology, and service come together to create exceptional cabinetry. With each step, the focus remains on delivering a flawless end product, combining both aesthetics and functionality. The Mosersweet House was constructed using a sustainable, timber-based building method. The foundation began with a reinforced concrete base, followed by the assembly of prefabricated wooden modules. These modules, crafted off-site, were transported and positioned precisely using a crane, significantly reducing on-site construction time and environmental disruption. Cross-laminated timber panels were used extensively for walls and floors, providing both strength and insulation. The structure incorporated energy-efficient windows and doors, contributing to passive heating and cooling. Electrical, plumbing, and ventilation systems were pre-integrated into modular units, streamlining installation. Exterior cladding and a green roof were added to enhance thermal performance and blend with the natural surroundings. The process emphasized minimal waste and adaptability, aligning with ecological principles and modern residential needs. In the realm of sustainable construction, cross-laminated timber stands out as a revolutionary material. This video offers an insightful look into each step from raw timber to finished panels. The journey begins with the selection of high-quality, sustainably sourced timber. These wooden boards are then layered perpendicularly and bonded using structural adhesives, forming robust panels. This cross-lamination technique enhances the strength and stability of the material, making it suitable for various structural applications. Once assembled, the panels undergo pressing and curing to ensure durability. Precision cutting follows, tailoring the panels to specific project requirements. This meticulous process not only ensures minimal waste, but also contributes to the efficiency of on-site construction. Throughout the manufacturing process, strict quality control measures are in place to guarantee the performance and longevity of each panel. The result is a versatile, eco-friendly building material that combines traditional craftsmanship with modern engineering. In Switzerland, large retailers demand efficient firewood processing for oversized logs. This advanced pezzolatto line addresses that need with a fully integrated system. The process starts with a heavy-duty log loader feeding large diameter logs up to 900 millimeters into the cutting unit. A chainsaw, or circular saw, slices the logs into uniform lengths, which are then transferred via hydraulic rollers to the splitting station. Here, powerful splitters, some exerting up to 70 tons of force, divide the wood into firewood-sized pieces. The system includes conveyors that transport both the processed firewood and residual waste to designated collection areas. An integrated dust extraction unit ensures a clean working environment. Once filled, collection bins are swapped out using automated lifters to streamline transitions. Sensors monitor log dimensions and adjust the splitting blades accordingly, optimizing each cycle. Operators can monitor the process via touchscreen interface, which provides real-time feedback on machine performance. Maintenance access points are strategically positioned to minimize downtime and simplify routine service. This setup allows a single operator to manage the entire process, enhancing productivity and reducing labor costs. By automating the handling of large logs, the system minimizes waste and maximizes output, meeting the high-volume demands of major retailers. The CKD Hollowing system is at the cutting edge of innovation in manufacturing. This video takes you inside the process, showcasing how this advanced system is designed and built. First, precision components are carefully assembled in the facility, ensuring each part fits perfectly. The system's unique hollowing technology is implemented to maximize material efficiency and reduce waste. Automated machinery plays a crucial role in streamlining operations, allowing for quick, accurate production. Once the components are assembled, testing ensures the system performs at its best. This process combines efficiency and quality, resulting in a high-performance product that meets demanding industrial standards. From start to finish, it's an efficient, precision-driven process. The integration of automation enhances productivity, reducing both time and costs. Each step is carefully monitored, guaranteeing consistency and performance throughout the production cycle. The VSP60 is a combined machine designed for processing large-diameter logs. The process starts by positioning the logs on the machine, where the chain cutting-off machine precisely cuts the logs into manageable sections. After the logs are cut, they are moved to the hydraulic wood splitter, which is operated manually with dual hydraulic controls. This splitter is equipped with a curved wedge and 4 orbital knives, ensuring efficient splitting. Each working cycle results in 5 logs, enhancing productivity. The combination of cutting and splitting functions allows for smooth, continuous operation, optimizing time, and reducing the need for multiple machines. The VSP60 is engineered for robust performance, handling even the toughest tasks in wood processing with ease. The hydraulic controls provide precise handling, reducing operator fatigue, and improving overall safety. With its versatile design, the machine is suitable for different wood sizes and types, making it ideal for various wood processing environments. Additionally, the compact design allows for easy integration into existing production lines, improving workflow efficiency. Step into the world of precision wood turning with the CKD Hollowing system. Mounted on a lathe, it provides a stable base for shaping deep vessels and intricate forms. Its solid frame reduces vibrations, while the design ensures precise control and consistent wall thickness. As the tool cuts, a built-in support keeps alignment, reducing strain and improving safety. Ideal for crafting vases or bowls, it brings accuracy and comfort to every project. The production process at Pride Manufacturing begins with high-quality wood boards, which are carefully shaped into dowels. These dowels are then processed into various products, including golf tees and wooden cigar tips. A major part of the production involves creating Lincoln logs. The wood is first cut into small pieces and then assembled into the iconic log shapes. The manufacturing process ensures precision at every step, from shaping to final assembly. The wood used in production comes from local forests in Maine, contributing to the state's economy. The process is powered by advanced forest growth models to predict wood availability, ensuring sustainable sourcing. With continuous investment in equipment and technology, Pride Manufacturing maintains a high standard of quality in every product produced, meeting the demands for American-made goods. Each product undergoes strict quality control to ensure durability and consistency. The company's commitment to innovation and efficiency drives the ongoing optimization of the production process. The process of making a solid wood door begins with selecting high-quality wood, carefully chosen for its durability and aesthetic appeal. The wood is first shaped using a precision CNC router, such as the CR Onsrud 4-axis G series. The machine starts by cutting the wood to the required size, ensuring accuracy and consistency. Once the panels are cut, they are routed to create smooth edges and profiles, which are key to the door's design. The CNC machine allows for intricate cuts, providing the precise detailing needed for a finished door. After the profiling, the pieces are assembled and fit together. Any additional features, like decorative panels or glass inlays, are added during the assembly process. The door is then carefully sanded to achieve a smooth, flawless surface. Special finishes or stains are applied to enhance the natural wood grain, further elevating its visual appeal. Finally, the door undergoes a quality inspection to ensure it meets the highest standards before being sealed and prepared for shipping. This process combines traditional craftsmanship with advanced technology, ensuring the production of high-quality, long-lasting solid wood doors. The attention to detail at every stage guarantees that each door meets both functional and aesthetic expectations. The process of crafting oak tanks and casks begins with selecting premium oak wood, renowned for its durability and the unique flavors it imparts. The wood is carefully cut into precise planks, ensuring each piece meets specific requirements. Once cut, the planks are carefully shaped, steamed, and bent to create the curved structure of the casks or tanks. This step is crucial for ensuring that each piece can hold liquids without compromising the integrity of the wood. Next, the staves are assembled and held together using metal hoops, creating the tight, leak-proof seal required for long-term storage. The oak's natural properties come into play, with the wood's porous structure allowing for a subtle exchange of air that enhances the maturation process, especially in the production of wine or spirits. The barrels undergo a process called toasting, where the inner surface of the wood is lightly charred to achieve the desired flavor profile. The toasting process is a delicate balance, influencing the taste and aroma of the final product. The intensity of the toasting can be adjusted based on the specific needs of the product being stored. Finally, the casks or tanks are carefully inspected for quality, ensuring they meet rigorous standards. This traditional process combines craftsmanship and modern technology, producing high-quality oak vessels that play a vital role in fermentation, aging, and storage. The focus on local sourcing of oak further enhances sustainability, ensuring the longevity of both the product and the craft itself. These vessels are essential in creating distinctive flavors, contributing to the quality of wines, spirits, and other fermented beverages. Creating a textured wooden bowl begins with selecting a piece of scrap wood, ideal for a quick yet satisfying woodworking project. Using a ball gouge, the wood is carefully carved to form the bowl's rough shape, starting with the outer edges. The tool is perfect for achieving smooth, rounded contours, which are key to the bowl's texture. Next, the interior of the bowl is hollowed out, giving it depth and a functional shape. After the basic form is carved, attention shifts to creating texture on the surface. The ball gouge is used to add intricate tactile patterns, turning the bowl into a unique piece of art. Finally, the bowl is sanded and finished, bringing out the natural wood grain. This simple yet effective technique allows for the creation of beautiful, handmade wooden bowls from scrap wood in just an hour. In this video, we witness the detailed process of barrel crafting at Tonelería Nacional, a company with a global presence. The process starts with a selection of high-quality oak, which is sourced from the best forests in Argentina, France, and the US. The oak is naturally seasoned to ensure its ideal characteristics for aging wine and spirits. After seasoning, the oak is carefully shaped into staves, which are then assembled into the barrel structure. Metal hoops are used to secure the staves together, ensuring a watertight, durable structure. The barrels are toasted to different levels, from light to strong, to develop the specific flavors needed for various beverages, such as wine, whiskey, and brandy. The toasting process enhances the wood's aromatic properties, contributing to the rich flavors that develop in the liquid over time. After toasting, the barrels are fitted with heads and meticulously sanded for a smooth finish. Each barrel is individually crafted to meet the precise requirements of its intended use. Skilled craftsmen oversee every step of the process, ensuring that each barrel is made to perfection. Quality control is a vital part of the process, with each barrel being tested to ensure it meets the highest standards. The company's expertise in barrel making is evident in their ability to meet the demands of wineries and distilleries across the globe, including countries such as Spain, Australia, Brazil, and New Zealand. This commitment to quality and craftsmanship has made them a trusted partner for some of the finest wineries in the world. Modern CNC wood lathes transform raw timber into finely detailed wooden components. The process begins by mounting the wood onto the lathe. As it rotates, CNC-guided tools carve complex patterns and shapes with high accuracy. With 2- and 4-axis systems, this technology enables efficient mass production of table legs, spindles, and decorative pieces. Turning raw timber into precise wooden components begins with the Nesto 2-axis CNC wood lathe. The operator mounts the wood securely on the rotating spindle. As the machine spins, CNC-guided cutting tools shape the wood into smooth, symmetrical profiles. The 2-axis system allows for detailed shaping along both length and diameter, ideal for creating furniture legs, balusters, and spindles. Each pass removes excess material with consistent depth, ensuring uniformity. Once carving is complete, the machine finishes with fine detailing, readying the product for sanding or coating. This efficient process combines traditional woodworking with automation, boosting both speed and accuracy in production. This advanced 4-axis CNC wood lathe begins by clamping multiple wooden blanks along a rotating spindle. As the spindle turns, synchronized cutting tools engage with high speed and accuracy. Unlike traditional lathes, the 4-axis configuration enables complex, multi-angle shaping in one continuous cycle. The system is optimized for mass production, allowing multiple parts to be carved simultaneously, ideal for identical furniture legs, balusters, or decorative columns. Throughout the process, precise toolpaths reduce waste and improve consistency. The machine's flexibility allows it to switch between designs with minimal setup time. Automatic adjustments between cuts maintain smooth transitions and uniform dimensions. Once shaping is complete, the machine executes fine detailing before the components move on to sanding or finishing. This system reflects recent advancements in production efficiency, labor optimization, and high-quality output in modern woodworking. The chair assembly process begins once all sanded parts are sorted into bins. The assembler collects components according to each order, typically 2 to 6 chairs per batch. Back legs, arms, and back panels are selected and inspected. Assembly starts by fitting and gluing the back skirt, followed by clamping from top to bottom to ensure a tight bond. After drying, backrests are sanded and the top rails are fitted. Next, the front legs and the front skirt are attached. Each chair is checked for stability and evenness. Finally, seats are installed if required, and the finished chairs are moved to the finishing room. Inside a quiet workshop in Louisville, Kentucky, woodworking becomes both art and philosophy. Daniel Chafin Furniture Makers handcrafts each piece, emphasizing honest joinery and thoughtful proportions. From sanding to final assembly, no shortcuts are taken. Their process embraces tactile craftsmanship, celebrating the value of durable, meaningful furniture, built to last for generations, not just years. In this video, we dive into the thorough production process of glued laminated timber, GLT, at Holz House, located in the Kirov region of Russia. Starting with the selection of premium timber from the company's own forest, the process ensures that each piece of wood meets the highest standards of sustainability. The wood undergoes an integrated production system where each step is executed with great precision, much like a well-oiled machine. The logs are first debarked and sliced into exact dimensions, followed by drying to achieve the optimal moisture level. After drying, the wood is sorted and classified based on its grade. The layers of timber are then bonded together with a specially formulated adhesive to form strong, durable laminated beams. These beams are placed under high pressure and then cut to the required sizes, ensuring uniformity and structural integrity. Once the beams are formed, they undergo a thorough inspection process to detect any imperfections, ensuring that only the highest quality material moves forward. The finished glued laminated timber is then ready to be used in constructing eco-friendly homes that are both energy efficient and sustainable. By maintaining a full-cycle production process, Holz House can guarantee superior quality and sustainable practices at every stage. The process also incorporates the latest technology to minimize waste and maximize the efficiency of production. Advanced machinery allows for precision cutting, ensuring that the material is used to its fullest potential. Skilled workers carefully monitor every stage of production, contributing their expertise to ensure that every piece meets the company's high standards. At Holz House, the seamless combination of technology and craftsmanship results in a continuous and efficient production line, capable of delivering high-quality timber products that are perfect for building sustainable, beautiful homes. This complete control over the entire production cycle reflects the company's commitment to producing eco-friendly and durable construction materials that contribute to a greener future. The company's dedicated approach allows them to produce timber that not only meets the demands of modern construction, but also supports sustainable living practices. By overseeing the entire production process, they ensure that each product is as environmentally friendly as possible. The use of locally sourced wood minimizes transportation impact, contributing to a reduction in carbon footprint. The high-performance timber is particularly suitable for building energy-efficient homes that require less heating and cooling, making it an ideal choice for environmentally conscious builders and homeowners. Each phase of production is executed with care, ensuring that the final product delivers lasting durability and excellent thermal insulation properties. Take a closer look at the construction of a passive house in Ames, featuring an innovative CLT, CrossLaminated Timber structure. Over the course of just 1 week, the entire wooden framework is assembled, showcasing the efficiency and precision of the process. The CLT panels, manufactured by Zillanor in Galicia, are expertly crafted to ensure strength, sustainability, and energy efficiency. These panels are then transported to the site, where the building structure comes to life under the guidance of the project's architects and engineers. The collaborative effort of the design and construction teams allows for a seamless integration of materials and design, ensuring a smooth and efficient build. This time-lapse highlights the versatility of CLT in modern construction, providing an environmentally friendly alternative to traditional building methods. The use of CLT not only enhances the building's thermal performance, but also reduces its carbon footprint. Additionally, the rapid assembly time and minimal waste generation make this method highly efficient and cost-effective. The result is a sustainable, high-performance home that sets a new standard for green construction. The ArborTech Contour Random Sander transforms wood shaping and sanding. This innovative tool fits directly onto any standard angle grinder, offering a powerful random sanding action that prevents wood burning. Its flexible sanding pads reach edges and corners, ensuring a smooth, flawless finish without damage.